Dear followers, welcome to this video tutorial that will guide you on how to interface a relay using Arduino and Proteus development environment. The relay switching here will permit you in order to switch on a device with a higher voltage supply. For example, you are utilizing the Arduino is being supplied at 5 volt, but you cannot utilize this voltage level in order to turn on, for example, a motor or a heater at 220 volt. So a device which is known as a relay will permit you to switch this load at that different voltage level. So you can utilize a relay to switch a load at a different voltage level, which is different from the voltage which you supply your control circuit. So we proceed by selecting the various components which we are going to utilize here. As you can see here, I've selected the various components here. In order to select these components, you come to component mode and pick device. Then you can search the diode. Here we are utilizing the 1N4007, which is a diode of 1 ampere. Then we are using a relay. We use a relay here. You select this relay. You can find relays of 5 volts, relays of 12 volt, but we are going to configure the voltage of the relay in order to energize the relay in the circuit. Then we are going to utilize the Arduino Uno. Here you have the Arduino Uno. We are going to utilize an alternator or an AC voltage source. Here is the AC voltage source that will permit to supply the motor. So you select as well a motor. Then a resistor and a transistor. We use the BC547 bipolar transistor, which is an NPN transistor with a power of 625 milliwatt. This transistor here will be used as a switch. You know, a transistor can be used either as a switch or as an amplifier. We are going to utilize it here as a switch in order to switch on the relay, on and off the relay. Then we are also going to use a push button here in order to give an active pulse to turn on the relay. So we start by placing the various components in the workspace. The Arduino Uno, you click on the Arduino Uno here and then you come and click in the workspace. Then you do same with the various components. Here we input the resistor, we input the transistor. The resistor here is used to bias the base of this transistor. Then you put in the relay. Double click on this relay. You can change the voltage level here. I have inputted 5 volt. This is the voltage required to energize the relay. You can also have relays of 12 volt based on the source which you're using to energize the relay from your control circuit. Then you can connect. I'm connecting the base of this relay to pin 8 of the microcontroller. Let me magnify. Then the collector of the bipolar transistor is connected here. Then you need a 5 volt supply. You can take this from here, the terminal mode. Then you click on power. You input it here, and then you double click and select VCC, which is the 5 volt. Okay. So you can now connect these to the relay, then a diode. The diode here connected at this terminal of the relay. This is what we call a freewheel diode. This freewheel diode will permit to counteract the back EMF that is caused when the relay switches, so that it doesn't affect your control circuit. It doesn't affect the microcontroller as well due to back EMF generated. Then you input the alternator. You connect the alternator to this terminal, and then the motor, you do a closed circuit to the AC source. Okay, so when the relay switches, this contact changes from this position to this other position, which will permit the AC voltage source to supply this motor. Now, in order to control this circuit to switch, I would like to utilize an input pin to activate the relay. Here we use the push button. I've already shown you how to how you can connect a push button to use it in such a circuit. That push button as well can be used in resetting the microcontroller, as you see here. So we have the pull-up resistor, and here is the push button. When you actuate on this push button, it will reset the microcontroller to start back the process. So I would like to connect the control push button to activate the microcontroller on pin 13 as such. Okay. So you make sure you supply it using 5 volt as well. Then I would like to use a LED that will indicate whether the motor is on or off. We'll connect it to any pin. Let's select pin 1. Okay, use a protective resistor to protect the LED, and make sure you calculate the value of the protective resistor based on the color of the LED. I've used the red LED here, and the value has been calculated to 160 ohm. Please, if you don't know how to calculate this, you can refer to the previous video tutorial which we made. Okay, then you proceed to the code. Here in the code, we begin by configuring the mode of the various pins as input or output. Here, the input pin is pin 13, which is our push button that we'll utilize to activate the relay. So pin 8, which is the relay circuit connected to pin 8, will be an output pin. Then the LED connected to pin 1 will also be an output pin. So we do the configuration using the command pin mode. So pin 1 is an output, which is the LED. Pin 8 is an output, which is the relay. Then pin 13 is an input, which is our push button. Okay, then we can initialize these output pins by putting them off using the command using digital write at the pin 1 and at pin 8 to be low. So here we have initialized the pin. Okay, then we move to the void loop function. The void loop function, we initialize the LED. We can configure the LED to be connected to pin 1 uh, using the variable int. Int signifies an integer. So the integer here, we are defining that LED is connected to pin 1. You can do the same with the other pins, the relay. So the integer relay is connected to pin 8, and as well the push button, which is at pin 13, we can declare these variables as integers. So relay, push button, LED, we have declared it as integers. So anywhere in our code, rather than using 1 or 8 or 13, we can rather use this LED, which makes it to be user friendly, or we use relay, or we use push button. Okay, we proceed. Then we use the command digital read in order to read if we have pressed the push button or not. So you notice here that we are reading from the push button, which is at pin 30. So that's why we use the command if digital read bracket button is equal to low. That means that if the push button is pressed, we know that it is pressed when it is low from the circuit. Since VCC here is at 5 volt, the 5 volt supply is always supplying this pin. But whenever we press this push button, rather than the current flowing to this pin, it rather flows to the ground, acting as a short circuit here. So it's because it is at low impedance than the pin. So this pin 13 now turns to be low. That's why we have that command as digital read at the push button being low. Okay, then we proceed. We use the command digital write. That means if the push button has been pressed, here we write a high state at the level of the relay to turn on the relay. So we are writing digital write relay high. Rather than putting 13 here, 8 here at the point at the level of relay, we can still use the name relay. This makes it user friendly. That's why we declared it as integers. Okay. So we also put on the LED high. Let's turn on the LED. Then we also use the command, the loop, in order to continually turn on this relay and LED. So we are going to input the while loop here so that if it is pressed, then it turns it on infinitely. Okay, we are going to come back to that. So if this command is not met, we use the else function. So else, we turn off the relay using the command digital write, relay low, and then we turn off the LED, the command digital write, relay digital write, LED low. Okay. So we can input our while loop here using the command while one. All that we put now all these command in a big braces. We close it here. So we can simulate. We run the compilation, done compiling. Then we copy the hex file. I've shown you how to copy the hex file. You come down here. You copy from C to .hex. I copy, then I come to the Arduino, I double click on it and I paste here. Then okay, we can run the simulation. So you see it is normally off. When we press, the motor comes on. You'll see the relay switching from this contact to this contact. You can reset the microcontroller by pressing the reset button here. You see everything stops. The microcontroller starts back and you can see press the start push button. It turns on the motor. You can stop or reset here. So you have seen how you can interface a relay. If you haven't yet subscribed to this channel, please subscribe, like, and share.